Number 1. A portable game player stops working because the batteries are dead. What type of energy does the game player need to begin working again? A. Mechanical energy. B. Thermal energy. C. Sound energy. D. None of the above. Number 2. In an activity, students are given a circuit diagram. Which statement explains why the buzzer will not sound when the switch is open? F. Sound energy from the buzzer cannot travel through the open switch. G. Electrical energy produced by the switch cannot travel through the opening to produce sound energy. H. Sound energy from the battery cannot travel to the buzzer through the open switch. Or J. Electrical energy from the battery cannot travel through the open switch to produce sound energy. Number 3. What do all the objects below have in common? A. They all refract light. B. They all reflect light. C. They are all conductors. Or D. They all make objects appear smaller. Number 4. Students use a spring scale to measure the differences in force when a block is moved across smooth and rough surfaces. What unit of measurement should the student use when recording the data? F. Centimeter. G. Celsius. H. Newton. J. Gram. Okay, you're going to use the information below and your knowledge of science to answer questions 5 and 6. Students design an experiment to demonstrate the flow of electricity in circuits. Some of the available materials are a battery holder, a light bulb holder, copper wires, and a switch. After testing objects that conduct electricity to prove that an electric current passes through, the students notice the light bulb is not shining as brightly. They decide to dispose of the battery and replace it with a new one. Number 5. Which of the following is a wise choice for disposal of the battery? A. Place the battery in an incinerator. B. Dispose of the battery in the trash. C. Place the battery in the recycling bin. Or D. All of the above. And number 6. Electricity can seriously harm people. Adults and students should be aware of electrical safety advice to avoid such things as electric shock. Which of the following is considered the most vital, which means important, piece of advice to follow when exploring electrical circuits? F. Always follow the teacher's directions. G. Always use new wire when building circuits. H. Always put materials away after building circuits. Or J. Always take the advice of your group members. Number 7. A boy pushes a cart across the floor. What is the push most likely to change? A. The mass of the cart. B. The shape of the cart. C. The position of the cart. Or D. All of the above. Number 8. Which kind of energy is produced by the bulb in the circuit? F. Electrical. G. Mechanical. H. Light. or J, sound? Number 9. Students are asked to construct a graphic organizer to assist with organizing data on the study of light. How light behaves: reflects, which light bounces, and question mark, and refracts, which light bends. An example is a hand lens. Which of the following is needed to complete the graphic organizer? A wooden boat, camera, a shoebox, or a mirror? Number 10. Which motion causes a flag to be raised or lowered from the flagpole? F, a back and forth motion. G, a push or pull force. H, a magnetic attraction. Or J, rubbing together of surfaces? Number 11. Which of the following produces mechanical energy? A, an outlet plug. B, a flashlight. C, a burning campfire. Or D, riding a skateboard? Number 12. After an investigation demonstrating that a circuit requires a complete path so a current can pass, 4 students draw a diagram representing the experiment. Which student designs an accurate diagram of a closed circuit? Student A, Student B, Student C, Student D. In science class, students learn that to calculate force, they need to multiply mass times acceleration. If the mass of an object is 7 grams and the acceleration of an object is 20 kilometers per second, what is the force? Record your answer and fill in the bubbles below. Number 14. Which project will best test this statement? Objects pushed with the same force will slow down when moving across surfaces with more friction. F, build ramps and cover with materials like wax paper, foil, sandpaper, and carpet. Roll a ball down each ramp using the same amount of force. G, cover flat surfaces with different materials like carpet, silk, cotton, and wool. Roll a ball across each surface using different amounts of force. H, build ramps and cover with carpet or sandpaper. Roll a ball down each ramp using different amounts of force. Or J, cover a flat surface with silk and a ramp with cotton. Roll a ball across each using the same amount of force. On this one, remember, you can only have one variable. Number 15. Based on the advertisement, what can be inferred about the expansion of this mirror company? Magic Mirror is one of the fastest growing providers of standard and custom automotive mirrors in the world. Yes, the world. Yes, we are coming up fast, faster than the competition ever expected. 8 international locations and 11 U.S. distribution centers provide our customers access to the wildest range of high-quality commercial mirrors. For ordering information, contact us by phone or visit our website. So the question was, based on the advertisement, what can be inferred about the expansion of this mirror company? A, mirrors can be customized to fit any automobile. B, Magic Mirror is quickly becoming a top competitor. C, Magic Mirror provides mirror products only in the U.S. Or D, the company may be contacted by telephone only. Number 16. What is shown in the image below? F, the force needed to use a pulley. G, the path light takes when it is refracted. H, the flow of an electrical current. J, the path light takes when it is reflected. Number 17. After studying uses of energy, a student makes the following conclusion. Thermal energy is heat energy. Is the statement accurate? A, yes, thermal energy is also known as heat energy. B, no, thermal energy involves sound. C, no, thermal energy is energy converted from electricity. D, yes, thermal energy is converted into heat energy. Number 18. A student pushes against a brick wall with a force of 25 newtons, but the brick wall does not move. Does work take place? F, yes, because the student pushes with the force of 25 newtons. G, no, because the wall does not move. H, yes, because for every action there is an equal and opposite reaction. Or J, no, because the student does not use force. Okay, use the information in the story below and your knowledge of science to answer questions 19 and 20. Newton's law of motion. Isaac Newton was one of the world's most influential scientists. It is said that Isaac Newton began his discoveries about gravity after observing an apple fall from a tree. Whether the story is a myth or fact is unknown, but we do know Isaac Newton experimented with gravity and wrote the laws of motion. Newton's 3 laws are: first law of motion, an object at rest remains at rest, and an object in motion remains in motion unless acted upon by a force. Second law of motion. The acceleration of an object depends on its mass and the amount of force applied. Third law of motion. For every action, there is an equal and opposite reaction. Okay, number 19. 2 marbles collide, sending each marble into opposite directions. Which of Newton's laws best explains this event? A, the acceleration of an object depends on its mass and the amount of force applied. B, an object at rest remains at rest, and an object in motion remains in motion unless acted upon by a force. C, for every action, there's an equal and opposite reaction. Or D, gravity is a force that pulls objects towards each other. And number 20, the student places a stack of books on a chair with wheels. The teacher pushes the chair across the floor, but then stops the chair abruptly, which means quickly. The pile of books continues to move, flying forward and spilling onto the floor. Which Newton's law of motion does the teacher demonstrate? Remember, the teacher stopped the chair, but did the teacher stop the books? Okay, so which of Newton's law of motion does the teacher demonstrate? F, Newton's first law of motion. G, Newton's second law of motion. And H, Newton's third law of motion. J, not here.